In this video, we introduce a method to enhance interpretable object abstraction via clustering-based slot initialization. Object-centric representations using slots have shown the advances towards flexible and interpretable abstraction from low-level perceptual features in a compositional scene. However, current approaches randomize the initial state of slots followed by an iterative refinement, which significantly affects the accuracy and limits the efficiency during inference. Furthermore, current approaches require a predetermined number of slots from prior knowledge of the data, which limits the applicability in the real world. In our work, we propose conditional slot initialization using clustering algorithms instead of random initialization. We analyze the effect of permutation symmetry including invariance and equivariance on the object-centric slot representations, and apply mean-shift clustering on the visual features, which allows us to generate a flexible number of slots. Specifically, instead of randomizing slot initialization from a common distribution, we initialize slot representations conditioned on the input features. A clustering algorithm and a mapping layer are adopted. 3 variants are introduced in our work. We implement a non-permutation symmetric model using k-means clustering on the pixel-wise convolutional perceptual feature to get the feature-based cluster centers. Afterward, the cluster centers are flattened and mapped to the k-slots using MLPs. However, a simple mapping between M cluster centers and K slots breaks the permutation symmetry and cannot generalize well on unseen objects. Therefore, we propose a permutation invariant model named pseudo-weights, which uses positional encoding to identify different slots. The cluster centers are broadcasted along the slots and concatenated with the positional encoding to predict the weights which allocate the importance of the cluster centers to the different slots. The slots are then initialized as the weighted sum over the cluster centers by the predicted weights. To further improve the generalization, we perform the mean-shift clustering algorithm over the feature space to determine the number of cluster centers without predefined. A shared mapping layer is then applied to initialize the slots based on each cluster respectively. Thus, it is permutation equivariant since the order of slots changes correspondingly with respect to the order of the cluster centers. We evaluate the results on object discovery task. In general, learning inductive slot initialization from input features improves the performance on both baselines, where mean-shift models achieve the best performance consistently over all datasets and reconstruct more details. Notably, all our iodine-based variants achieve higher resolution than the ground truth image on MDS dataset. Afterward, we evaluate the generalization on increasing objects. Specifically, the models are trained on Clever 6 dataset but evaluated on Clever 10 dataset. We observe that baselines struggle with closed or overlapped objects by missing, mixing, or predicting the wrong color of objects, while our models can detect the overlapped objects without missing any object even for extremely difficult scenes. Furthermore, we evaluate the performance with different number of iterations while 5 iterations are used during training. All models demonstrate benefits with increasing iterations. Our method gains notable improvement at the first iteration, indicating the efficiency of the learned inductive slot initialization. Please refer to our paper for more details. Thank you.